Look right there. There's like a
Right
beaker
there.
right there. Right there.
Grab the glass.
There's a glass thing right there,
Can
man.
you see
Where?
A2 written on
Oh, here?
that? No.
Okay, look, there's A2 written.
Right
Yeah.
here. Ah. Hey guys, it's Theo. I'm a 15-year-old who is extremely passionate about climate change solutions, in particular solar and wind. For the last few months, I've been looking into these renewable technologies, and what I kind of realized was that wind and solar in particular are the cheapest forms of energy in the world, even cheaper than fossil fuels. So then why isn't everyone using solar? The reason is that solar is intermittent, which means that it doesn't work 24 hours a day, as the sun isn't always shining and the wind isn't always blowing. So then how can we eliminate the intermittency that comes with solar and wind? Well, batteries. Batteries are a way to store energy, and they are key to the electrification of our planet. So that's why for the last 2 months, I've been going deep inside the battery field, and even built a lithium-ion battery in the lab. But before I talk about my epic lab experience, I'd like to just brush you up on what a lithium-ion battery is. So if you can think of a lithium-ion battery, it's mainly composed of 3 things: a cathode, an anode, and an electrolyte. The cathode is the positive terminal, and the anode is the negative terminal. During the discharge, the lithium atoms start here in the anode, wedged in between these layers of graphite. This is called intercalation. Now, one thing I didn't mention about lithium is it really wants to get rid of its one valence electron in its outer layer. So when there's a pathway from the negative terminal to the positive terminal in the form of a circuit, the electrons leave and are attracted to the positive terminal. Since the lithium atoms are now missing their valence electrons, they become ions, and they want to rejoin their electrons at the cathode. So they move through this thing called the electrolyte, a solution of lithium hexafluorophosphate, which is a lithium salt, dissolved in organic solvents, which are carbon-based solvents. The cathode is usually composed of lithium, a metal, and oxygen, making it a lithium metal oxide. And the anode is usually composed of graphite. If you want to learn more about the subject, I have an article and a video that go deep into lithium-ion batteries, explaining it in 4 different levels. Now that we've brushed up a bit on our lithium-ion battery theory, what type of lithium-ion battery did I make? Well, there are several different types of lithium-ion batteries, including lithium oxide, cobalt, lithium titanium. Anyways, the type of lithium-ion battery that I built in the lab is called LFP, or lithium iron phosphate battery. This battery is normally used in electric cars because of its high stability. I built what we called a half cell, meaning 1 electrode, the positive terminal meaning the cathode. Before we get into the experience, just wanted to say I have an article that goes through the experience, but in a way deeper way. If you prefer video, then you can keep watching this, but I'll still link it in the description if you want to learn more. For this experience, I needed copper as the current collector, lithium hexafluorophosphate dissolved in organic solvents, pure lithium, a porous separator, a spacer, a spring, iron phosphate bonded to carbon, which is the active material. Probably the hardest thing I did during this experience was getting my hands inside the glove box. This glove box is a 0 oxygen space because oxygen reacts badly with the organic solvents in the electrolyte. There's a copper catalyst inside the glove box that sucks all the oxygen outside of the space. After 5 minutes of putting my hands inside the glove box, it was time to build my battery cell. Getting the pure lithium and scratching the surface, then cutting the lithium into small circle for my coin cell. After I had my lithium, I poured the electrolyte solution into a plastic container and put my porous separator to lay inside the electrolyte solution. Afterwards, I took my case and poured 1 drop of the electrolyte solution into it. Then taking my iron phosphate, putting it over the 1 drop of electrolyte, and surrounding it again by putting 2 drops of electrolyte solution over it. Then, putting the porous separator over the cathode material. Afterwards, putting 2 more drops of electrolyte solution over that. Time for the lithium, putting the lithium over the separator and centering it. then putting the spacer, which helps not move the lithium, and putting in the spring. One last thing, which is closing the case, squishing the battery so that everything is closer together. Then, in order to make all the parts stay in place, we put the cell into this funky looking machine that squishes it all together. And there it is, my first lithium-ion half cell. Afterwards, me, my brother, my friend, and the PhD student that showed us how to make our own lithium-ion batteries had a competition for who had the best battery voltage. The PhD student had 3.1 volts, my friend had 3.2 volts, my brother had 2.8 volts, and I had the least amount of voltage with 2.7 volts. Sadly, I lost the open circuit competition, but what I gained was a huge amount of knowledge. And also, probably the best souvenir you can ever have, my own lithium-ion battery coin cell. Anyways, I just want to thank UCAM, the PhD students I met, as well as Professor Steen, who helped me accumulate a huge amount of knowledge during this journey. The number of insights I've had just by building my own battery cell was just insane, and I just really want to thank everyone who helped me on this journey, especially Professor Steen, who gave me this opportunity. Thank you so much for watching this video. I hope you learned something. I hope you took away something. If you want to follow me on LinkedIn or any other social media platform, you can, and go check out my other videos if you're really interested in lithium-ion batteries as well as climate change solutions. I'll see you next time.